On behalf of Rohini College of Engineering and Technology, I welcome you all. I am Verslin Baby, Assistant Professor, Department of Physics, Rohini College of Engineering and Technology. I am handling the subject Physics for Electronics Engineering. The subject code is PH8253. Now I am going to explain about semiconducting materials, which is under the unit Semiconductor Physics. After completing this course, the students will be able to recall semiconducting materials and its types. First of all, what is meant by semiconducting materials? The definition is materials which are partially conductors and partially insulators are called semiconducting materials. Based on energy band, a semiconductor has nearly empty conduction band and almost filled valence band with very small energy gap. That is, the energy gap is nearly 1 electron volt. Next, based on the element present in the periodic table, we can classify as elemental and compound semiconductors. First of all, elemental semiconductors. What is mean by elemental semiconductors? The example for elemental semiconductors is germanium and silicon. Now, what is elemental semiconductors? That is semiconductors which are made from a single element of fourth group elements of the periodic table. These elemental semiconductors are also known as indirect bandgap semiconductors. Next one is compound semiconductors, that is example gallium phosphide and gallium arsenide. Here compound semiconductors which are formed by combining third and fifth group elements or second and sixth group elements in the periodic table. This is also known as direct band semiconductors. Next one is depending upon the impurity present in the semiconductor, we can classify this as two types, that is intrinsic semiconductors and extrinsic semiconductors. Based on the purity of semiconductor that are classified into two, that is intrinsic semiconductors and extrinsic semiconductor. Next one is intrinsic semiconductor, that is a pure form of semiconductor is called intrinsic semiconductor. At 0 Kelvin temperature, the conduction band is empty and the valence band is completely filled. Therefore, it behaves as an insulator. When the temperature is increased, the electrons are moving from valence band to conduction band. See this diagram. In the first diagram is at 0 Kelvin. Here the two bands are there, valence band and conduction band. In valence bands are fully filled and the conduction bands are empty. But when the temperature is increased, the electrons from valence band moving to conduction band. Therefore, hence there are free electrons in the conduction band to produce current. Hence it behaves as conductor. From this, we can conclude that at 0 Kelvin, the semiconductor behaves as insulator. When we increase the temperature, the semiconductor behaves as conductor. In intrinsic semiconductor, number of electrons in conduction band is equal to number of electrons in valence band. Next one is extrinsic semiconductor. Impure form of semiconductor is called extrinsic semiconductor. The extrinsic semiconductors are produced by adding impurity with the pure semiconductor. Addition of impurity with the pure semiconductor is called doping. This addition of impurity increases the number of free electrons and holes, and hence its conductivity increases. Depending upon the types of impurity, the extrinsic semiconductors are classified into two types, that is N-type semiconductor and P-type semiconductor. First, we see about N-type semiconductor. When a pentavalent impurity is added with a pure semiconductor, it is called N-type semiconductor. When a trivalent impurity is added with the pure semiconductor, it is called as P-type semiconductor. The last one is general properties of semiconductor. First property, they have empty conduction band and filled valence band at 0 Kelvin. They are formed by covalent bonds. They have small energy gap. They possess crystalline structure. They have negative temperature coefficient of resistance. If the impurities are added to the semiconductor, its electrical conductivity increases. Similarly, if the temperature of the semiconductor increased, its electrical conductivity also increases. These are the general properties of the semiconductor. Thank you.